The project that I describe here is called Machine Learning for the Future Circular Collider Design, and it is related to the physics and dynamics of particle accelerators. We pursue this project at the Laboratory for Particle Accelerator Physics at EPFL in collaboration with STSC, of course, CERN, PSI, and the Swiss CHART initiative. On the photo on the right side, you see the proposed 100-kilometer ring collider together with the existing LHC. Many scientists are actually working on this design study, and it is an important aspect to optimize the large parameter space for maximum beam stability that would then also result in better collider performance. In the image below the photo, you see an evaluation of one particular configuration of the ring, and each dot represents a particle that has been followed numerically for 1 million turns while it passes several 10,000 magnetic elements during each turn. Those particles are started with varying deviation from the beam center. Particles at large amplitude feel nonlinear forces. They enter a chaotic motion and get lost. The yellow particles closer to the center are stable. You may guess from the image that the topology of the phase space is quite complex for such a dynamical problem. To express it in a simple way, we want to maximize the yellow region by varying all accessible parameters of this accelerator. In a brute force approach, a huge computational effort would be required to do that. And at this point, the technology of machine learning comes in. We believe that the large parameter space can be explored in a more intelligent way, in that we focus the probing of the dynamical system to the critical regions. With the resulting optimized machine learning model, it should be possible to interpolate the phase space with much less probing. As a result, we will be able to maximize the performance of the collider, and we can specify required field tolerances of the magnets. Such tolerances are important for the feasibility of magnet design, and they will have an impact on the overall cost. Thank you for your attention.